Here board module, individual LED are used with distinct roles. The red LED indicates the player 1 position, the blue LED shows player 2 position, the green LEDs marks both bottom and top of a ladder, and the yellow LED shows snake's head and tail position. The board has total 16 blocks. Each block contains 4 LED that represents full game information. All LEDs shares all LEDs shares a common power supply. To all LEDs anode shares a common power supply as since the LED are designed as active law components. On a 4-bit binary, binary number is applied to the LED board. The corresponding LED matching is equivalent and then LED lights up. Additionally, is to the decision to use a common anode for power supply helps reduces the number of ICs needed. This is because a widely available active load decoder outputs 0 instead of 1. This is an active load decoder which gives output 0 instead of 1. Because of this, we have to use extra NOT gate for all LEDs. This requires extra number of ICs, which is not an optimized version for our PCB. So we have to use this anode as common power supply to overcome this problem. Finally, all LED connections are combined to form the complete configuration. Thank you. This is the snake ladder logic module subcircuit. In this module, there we use ladder, mux, comparator, and demux. This is the complete 4 input, 8 output demux. How did this demux works? This is the selection button between player 1 and player 2. When first of all we come to this ladder. This adder adds player position and dice value to this adder, and output of this adder are sum of player position and dice position. This output will be this output gone to this marks, and this marks operates on selection button come. This selection button is the input output of this ladder carry. Why this marks is used? Because the when player position and dice value sum value is above 15, then it gives some carry. This carry, that means this carry will works as a selection button. On this it gives some carry, then it select B. What is the B? B is the current player position. Then it passes the current player position when the player position and dice value is above 15. So this marks is for that purpose. And then the ladder comparator compare between ladder bottom position and player position. When these positions are matched, then A is equal to B gives output 1. This output 1 enables this AND gate. This AND gate passes ladder length and added to the current player position. This ladder output also go to this multiplexer. Why this multiplexer? When the length is and current position added, and when it goes to above 15, then it cancel out the ladder length and remain the player position as initial one. So this max is used for that purpose. After this max output, it will go to snake comparator and this snake subcircuit. Why this? Because we prioritize first ladder position, then snake will come. When in one position, snake and ladder both will come, then we prioritize ladder position. So this because of this, first of all, ladder function works, then it goes to output. The snake will not work as we prioritize this ladder position. For stack position, stack comparator compares between stack head and player current position. If this matched, then this AND gate will enabled and passes the snake length. This snake length subtracted to the current player position, and because of this output of the snake subtractor will go to these marks. Why these marks? It also when this subtracted value is less than 0 or below 0, then it cancel out the ladder length and remain the player in initial player position as intact. Then this multiplexer outputs go to this demultiplexer. However, this is the selection button between player 1 and player 2. When 0 is come, then player 1 activated. When 1 is come, then player 2 activate. This is the working procedure. Now I run this circuit and show the above circuit. For this stack ladder logic circuit, this circuit is a special feature of dice value 1. This working principle of this circuit is on compare between player position and 0. When player position is equal to 0, then it passes A is equal to B1 and A is greater than B is equal to 0. When player position is 0, then it passes 1 and gate will all activate. And when player position is 1, this and gate will also passes 1. Then ultimately this 2 input 1 1 output will also 1. Then output for 1 the marks selection B. Select B. What is the value of B? B is the dice value. So dice value will also passes to this marks 2. When dice value is 3 and player position is 0, then it passes 0. Why? Because 3 it deactivate this AND gate and comparator is equal to B is not equal to 0. Then it will also give output 0. For selection button 0, it gives output A. A is equal to what? Grounded or like grounded, like 0. So output will remain past 0 as it is 0. And it will also come 2. Then it will also work as same as 3. It will work when dice value is 1. And dice value is 1. This circuit is completely a special feature of this dice value 1. At initial position is 0. When player position is 2 or have some value of player position, then this circuit will not works properly. Like will not works. When player position have some value, then dice value is 1, it passes 1. When dice value 3, it passes 3. When dice value 2, it also passes 2. So when player position have some value, this circuit will not works. So when player position is 0, then it will works for when dice value is 1, then it works properly. This is the special feature I have discussed in this logic module. Then finally we see this circuit is how this circuit gonna works. So now this IC is adder. So first of all we keep player position 2 and dice value is 1. So 2 and 1 is output gonna be 3. So this is the selection button of these demarks. It's selection between player 1 and player 2. When 0 comes, then player 1 activated, and when 1 comes, then player 2 activated. So this adder also works properly. After this adder output goes to these marks. Why will you use these marks? Because when player position is like 14 and dice value is 3, 14 is and 3 is equal to what? 17. So 17 is above 15. So it passes some carry. This carry works as a selection button of these marks. So it passes B value. What is the B value? B value is the initial player position. So it passes 14. Here is the output of this 14. See, 17 will not passes. Why? Because of these marks. So these marks will also works perfectly. After then, we use this ladder bottom position. We keep this player position to 2 and 3. Dice value is 3. Then 2 and 3 is equal to 5. This is 5. And we keep this ladder bottom position also 5. Then this ladder land will also keep 5. Then 5 plus 5 is equal to 10. See, this output is equal to 10. So ladder also works perfectly. There have some invalid case also. Ladder position is when above 15, then it will not passes. Like on 5 and like 10. This is 14. 5 plus 14. It will remain same. So this carrier will passes 1. Because of this 1, it will remain the same as player position. So this is the invalid case. And next we got to snake comparator. First we priority this ladder, then snake. When two ladder bottom and snake head are gonna be same position, then the priority will ladder. When ladder is something, then it works properly, but not for snake, because as we priority this ladder, then after we works how this snake computer works. Like we remain this as 8, 10. 10 plus 3 is equal to 13. See, this is 13, and we place snake head to 13. Here is 13, and snake length to 13. Then it will remain 0. See, it will remain 0 value. Then it will remain 0. When snake length is like 3, 3 minus 13 minus 3, it will go to 10. See, snake position will also works perfectly. These are the complete overview of snake ladder logic module. Thank you. This module, it contains memory module, winning module, and reset module. In memory module, we use 1 DMux and 3 mux. And for your store data, we use two parallel in, parallel out data register. And now, when player 1 is playing, then this register will remain on, and this will become off. And when player 2 is playing, then this register is off, and this will turn on. For each player, there will be one register on, and this multiplexer is have their special uses. This multiplexer is to show the real-time data for current player position. When this multiplexer selection button is shorted to this DMux. When player 1 is playing, and it stores it shorted to this multiplexer A value, and B value is shorted to this data register output. Because of this triggering, when player 1 is playing, it will show this player 1 position value, and next trigger it will also store this data this to this. This data will also show as in this value. So if we run this circuit, we can see that for player 1 position, player 1 is currently at 3 position, and player 2 is currently at 2 position. We have to store this data and to this data register. So 0 is for player 1 and 1 is for player 2. When 1 comes, then player 2 playing, and when 0 comes, then player 1 playing. This is the player selector output, and this is the dice value output. When player selector is 0, then player 1 is playing. So we have to store this data to this data register. So we have to trigger and like push the dice value. When we push the dice value 0 to 1, then it trigger and save the current data to this data register. For player 2, we have to change this player selector 0 to 1. When 0 to 1 goes, then we have to push the dice value again. When we push the dice value again, then it will also save this data to this data register and show the corresponding output value and lights up the LED. This is for the player selection between player 1 and player 2. Here, when player 1 or 2 comes 15, then buzzer will turn on. like I said, on player 1 is 15. Then buzzer will on. On player 2 is 15. Then buzzer will also on. This is the complete demonstration of memory module and reset module. In for reset module, here we have to push the reset button, then automatically memory data will be reset. When we push it, then memory data will automatically reset. This is the all demonstration I have shown in this sub-circuit. Thank you. This is the whole integration of the circuit. Here this is the memory module, this is player decoder, this is warning module, this is the reset module, snake, ladder, logic module, and this is snake position decoder, and this is ladder position decoder. These whole circuit are dice module and player selector module. Now we demonstrate the gameplay. When we run the circuit, or initially player position is 0, and we have not yet given the value of ladder length and head, or snake head or tail. So this position remains 0. As when we give the ladder snake head to 13 value, and snake tail, snake length rule is 10, 8 plus 2, 10. Then 13 LED will blink up, and 13 minus 10 is equal to 3. Then 3 LED will also blink up. Here 13 LED is turned on, and 3 LED is also turned on. For ladder bottom, for we keep it 4, and for length that is gonna be 8. So 4 plus 8 is equal to 12. So 12 LED will, for 12 LED is turned on, and for LED is also turned on. Now we roll the dice. It comes 1. So player 2 is playing. So player 2 current position is 1. Next turn is for player 1. Player 1 is dice value comes 2, but output remains 0. Why? As we previously discussed this. When dice value come 1, then it will start the game for individual player. But in this time, this player 1 position, the dice value comes 2, so output will remain 0. So next rolling, player 2 is playing. When player 2 is playing, then previously player 2 is 1. 1 plus 3 is equal to 4. But at 4 position, ladder length, ladder bottom here. Ladder bottom is here, so it will directed to the 12 position. So player 2 current position is 12. And now player 1. Now player 1 comes 1. So for player 1, LED is turned on. Now it will automatically directed to player 2. Previously player 2 is 12. 12 plus 2 is equal to 14. So player 2 current position is 14. So 14 LED will blink, is blinking. Now this is for player 1. Previously player 1 is 1. Now this is 2. 1 plus 2 is equal to 3. So player position, so player 3 LED is turned on for player 1. For player 2. For player 2 it comes 2, but previously it comes 14. 14 plus 2 is equal to 16. So this is an invalid case. So it gives the previous value. So player 2 remain at same for 14 position. Now for player 1 turns 1. Previously at 3. 3 plus 1 is equal to 4. As we see that in 4 there is a ladder bottom, so it automatically directed to 12. So 12 LED of player 1 is turned on. Then player 2, it also comes 2. So this is also invalid case. So it will remain same. It will remain same. and it is for player 1. Player 1 is 1 win the game. So we have to reset the circuit. So when push the circuit, then it automatically reset the player 1 position to 1 and 2 position to 0. Here this reset function works. This is the complete gameplay demonstration I have shown this video. Thank you.